Okay, hello everyone. I'm just going to go over to my screen now and share. So I hope everyone sees my PowerPoint on there, what I've got on there. Yeah, is my PowerPoint on there? Yeah. So, yeah, I'm Pat Link. I'm at Neston High School. So I am the lead engineer teacher here, and I'm the STEAM coordinator. So we call it STEAM, so we put art into STEM as well. And I set up a Makerspace. So how I started my whole journey with this is when I look back at it, I started university in 2012. So I went there. Well, actually, I graduated, saying that wrong way around. I graduated in 2012 from Major University. We had the end of year project. What we had to do as the end of year project, we had to think about something sustainable and deliver that. And I always a believer is you make something and you want to have it long lasting, sort of thing like that. So I had a fleece jacket there, which I discovered was made from recycled plastic bottles. And I've had that for 20 plus years prior to that. So that's been a long way around. So I looked at this, how I could start recycling. And I came across Dave Hawkins. He started in 2012, the precious plastic journey. If anybody's heard of that, they're coming up to version 5 now. So you get blueprints to make machines. As you can see there, I started out with a panini maker and a pair of scissors, and then literally started making up plastic things with that to get students engaged. And I was looking at sustainability recycling because that's what I did my project about. I then got money together and bought my first shredder, which you can see is the wooden one there. And I sort of try to document that whole journey going along. But for me, that was not just to do that, but I wanted to bring the classroom to come alive. So me getting the classroom to come alive was starting in engineering, then building machines, obviously to do our plastic recycling, because precious plastic gave you those plans out. And we then, as you can see there, we turned on the lathe, the plastic that we made. There was a good resource for it, so really well. But I had then students who wanted to do Arclight scholarships, and they'd done projects like this then, making, like, for example, the welding around the nozzle that we've made on our injection molder. Over the time that we've done it, we've built then 3 machines, actually 4 machines. One's not on there. The machines are sheet press. That's the latest one we have. But we went from just having a simple, like the middle one, a press, because you need to, if you make plastic, you need to somehow form it, sort of thing. When you're doing it coming out of an oven, you can twist it, turn it, but you need to actually compress it into some kind of mold. And over the years, then we sort of won different kinds of awards with doing this project. So students got really engaged with that, became a silver and then a gold STEM club. But all that to get to that point took a long time. So I've probably a journey of 5-6 years. I've been at Neston now for 8. So I started literally Makerspace right from the beginning, coming through, trying to do that. So what I had then is, as you can see there, we reckon on account probably 800,000 bottle tops we've recycled since I've started doing this. And you can see that was just like was collected in school in 6 weeks, what's lying on the floor there on the left-hand side. Then we had got it in front of the washing machine, because obviously plastic has to be clean if you want to actually do something with it. So it has to clean plastic, goes to clean plastic. So we have a dedicated washing machine in DT that's just there for washing bottle tops. And as we washed them, then we sorted them into colors. We then, lucky enough, I managed to talk the council into buying us a scanner. So we have a dedicated scanner there that actually will scan what kind of plastic it is and gives us like a reading on it. So to give that, but then that actually branched out further then, that even parents of students that you can see on the video there, on the slide, they actually wanted to get engaged with it as well. And that became like a big thing. So quite regularly, we do a parents, Makerspace, and you see their students, for example, the one at the first picture you see in the top left there, when you see those 2 students there, really active. Ben, he's actually really engaged with even the new project we started, which I'll talk about in a second. And then Penny, who stands next to me there, they got so engaged with this. And it's great when you inspire your kids so young into that. So I've taken students from year 7 all the way to year 13, and they've gone into sustainable jobs then, and looking at that as for an industry to go into, which has been a really great thing. So as you can see, that there on account, that is 6 weeks of bottle tops all packed together, sitting in those trays that you have there. And you can see that in the picture at the bottom there, Annie, that was our first shredder that we had. And that used to shred plastic. And obviously you had to hold the top down onto it because they all got micro switches on. So that was the safety feature on everything. So everything is really approved. We had approved by the council when we built the things that we had on there. So that was really good. That things got approved that way. Then obviously we have our sorting. You can see up there, that's what you end up. Ryan's been to my room. I think Jenny, who's on the call, has been to my room. You can see the amount of plastic that we have stored already away in colors and put together like that. So it becomes a really big thing. But to me, that wasn't just enough doing that as a makerspace club. I looked at then the greater thing, what we've done. We achieved all those things, but how can we bring it to the classroom? So we started then redesigning our curriculum. This was before the government came in with this new thing, sustainability, to come into it. We started this 7 years ago, restructuring our thing. So we used to make friendship bracelets. We in year 7 we still make the hook. So the key ring that you see on the bag there. So students will all make a wooden mold, a wooden MDF version first, and then they make a plastic version of their key ring. We tend to cut letters out because it's quite an enjoyable thing. But we've done sustainable things like looking at making wind turbines. Some students started putting plastic into that as well and start using it that way. But then what I started to do is not just a Key Stage 3, but Key Stage 4 and 5 to bring it into. So for examples, you can see the laptop stand there is the right-hand picture. Year 13 students on the OCR engineering course that we unfortunately finished this year, so hope we can get a new project where that comes into it. What they all made is they all designed and made their own plastic sheet, and from that they made a flat pack laptop stand. And that's been a really enjoyable thing to learn CAD/CAM and actually produce something like that. And those 6 students that you see standing there together, they've done 5 of them are in my engineering course. 1 isn't in my engineering course, but his brother was in my engineering course, and he's just came along to do the same for DAV. What they've done is they've collected crisp packets, and those crisp packets, we washed them all out and we made a sleeping bag out of that. And they raised, I think it's about £600 or something like that for a homeless charity, which was really good for youth homeless charity. Which I think was a great project. They've done it over a couple of weeks. They enjoyed it that much, they would come back more and more to make that, and get involved with that, because they only were going to do over 10 weeks or something like that. But they really enjoyed that. And this year we're doing, we have to make an engineer square for one of our engineering ones. So we actually make the bottom stock. That's milk bottles, that's HDP. We milled that actually out. That's been a really enjoyable one. Top there, you can see we have a filament maker. That's our newest thing we bought from Sustainable Design. So we bought a filament maker, and with that, we've been turning in, because students always want to 3D print. So now we're turning plastic bottles into something that's 3D printed, comes on there. But probably our favorite project of all is you can see on this picture here, because they're always amazed, say you can sew, sort of thing like that, So we actually make a plastic wallet. So we use plastic bags, as you can see on the background there, they get arranged in all different things. And we have Omni cards, they call them, those cards they use for buying food in school and stuff like that. And that's what they use off that. So they just like you sewing together. They learn techniques of actually making a plastic sheet, sewing it together. And that's a makerspace. You can see loads of students in the background. So everyone's always doing something and getting involved that way. So it becomes a really great thing. That's a really enjoyable project. So the next thing we're going to try is make something bigger, which is a bag. That's what they challenged me to now. So we're going to try and see what we can come up there with. And in our classroom, then we have those only 5 of 10 chairs that are made out of recycled plastic. You can see they've been all CNC cut. All the ones that have been CNC cut. The offcuts have made the middle chairs on that one. So there's 5 of those middle chairs, which are second recycled plastics. At the bottom, you can see there's another one. We have a hand cranked extruder, which is a really great thing for students. We have our large injection molder, but that hand cranked one is much easier for them to operate, sitting on the side there. The reason I'm holding that one on that picture is because we didn't have it fastened down to a bench. You do have to fasten the tools down when you're doing it. And a great group that we set up is, because since it's been going, it says Schools for Recycling Plastic, as a group you can join. There's loads of information in there where that happens. So if you scan that QR code, that takes you directly to the page, and the other one takes you over to our page that is the Instagram page that I run. I think I've run a TikTok page as well now. Rarely use that, but year 7s were really keen on getting that. But I'd rather just stay at Instagram to share the stuff on there. So I hope I haven't gone over my 14 minutes there or undercut that, I hope.
No, all good, Pat. I should have said right at the start, if you've got any questions, we'll have time at the end. Everybody's going to be speaking for about 15 minutes. But if you have got anything, if you want to drop it into the Q&A sort of chat part of it, then we can collate those at the end and we can ask either Pat, Rory or Tom. Cool. Thank you, Pat. I'm sure we'll come back to you near the end.
Thank you. I'll stop sharing. Yeah.
Cheers. Right, over to Rory.
There we go. I muted myself. Let's go full screen. Cool. You can all hear me? All right.
Okay.
Perfect. Right. So thank you for having me. Yes, I'm Rory from Sustainable Design Studio. Some of you may already have met me in the real world. But yes, I created Sustainable Design Studio about 5 years ago. And our principal focus is really connecting the dots between plastic waste and products. So we're not specifically education, but we are very much about sustainability. And I think Pat is a great person to come after, to be after his presentation because he showed the value of a bottle cap, I think. And normally, I ask people at the beginning of lectures, how much do you think this is worth? Is it worth anything? If you saw that on the side of the street, would you pick it up? And if I tried to sell it to you, how much would you give me any money? I think most people would say, not worth anything, no thanks. But in reality, that's the problem. 9% of the world's plastic is recycled currently. And unfortunately, of that 9% or of the world's plastic, 8% of all plastic ends up in the ocean. And the reality here is because it is valued as nothing. And as a result, it ends up in waterways. And these are all photos I've taken myself on my travels and my work. And hopefully you can see this, it's smooth enough or to give you a sense of context. But this is the Gambia. There's a great video I did on YouTube about this whole project, but it affects people's lives. And in reality, we don't see it day to day, but actually we're just very good at hiding it. The problem is still the same. And again, this is another place, again in the Gambia, but you can see it's being burnt. There's livestock there, trying to scrape whatever food. And at the same time, people are working on trying to scavenge some of this material. But, if you want to recycle it, the normal system is big industrial machines. This is a machine in Bangladesh making the plastic on top of your sandals. And they're big, expensive, scary pieces of equipment. And that's where a Sustainable Design Studio kind of comes in. The reality is that melting plastic or recycling plastic is inherently easy. You just have to take it, make it a little bit smaller, and then apply some heat and pressure to get it to work. So that's why you may see people using penny presses. That is the principle. And that's a great way of starting your workspace. But if you want to make something a little bit nicer, a little bit more fancy, then you've got to take a small step up. And that's where Sustainable Design Studio has been working on trying to break the boundary down. And so what we do is for all our clients, whether they're schools or big companies, we develop the machines, we can design products for you, we do training, and we do consultancy. But I don't want to turn this into a sales pitch. It's more about talking about how we can break some boundaries. So yeah, so the basic is you shred the material, you need a machine to press it, and then you need some molds. Inherently, after a few years, we realized molds were the hardest thing to achieve. But I'll jump into that. The Sustainable Design Studio, we're focused on sustainability in every way. So in terms of how we make our products. And so we look at product design and how much carbon is used in our equipment. So this is something that we have at a value that can become a lesson on its own about product design. How do you design something to be sustainable? And you can look at how the machines are made to do this. And actually, to purchase one of our injection minis, you would just need to eat collectively as a class 7.9 kilos less less beef, sorry, or 43.2 kilos less plastic, to offset the carbon of your machine. And again, we want our equipment to be an educational lesson. So in terms of designing sustainability, every machine comes with a step-by-step instructions of how to assemble and build that machine, to repair, to maintain. We want this to be the last injection machine you ever buy. And as a result, this kind of idea of teaching about everything online, we provide all the information free. Just go to our website /resources, and you will find information on plastic types, identification, how to use PLA from 3D prints to be recycled, and how to create your own molds, and some great case studies. And I'm going to jump into that now. So one of our kind of key products, or one of the things we designed very specifically for schools, was the filament maker, and Pat showed this. And the key here was, when we designed this, how do we create the easiest or quickest way to demonstrate recycling in the classroom? How do we take an object in a 1-hour session and turn it into something new with as little investment as possible? And the filament maker kind of felt like the easiest way to do this. And so the way this is achieved is there's 3 videos here. Hopefully you can see them. But you peel the bottle. You take any water bottle or similar. You peel it. You put it into the filament maker as a strip, and then you melt it down, or reform it into the filament that you can use in most standard printers. It prints very similarly to PETG. So if your printer can handle that, then it's a very similar material. And then you can see we're feeding it into various different printers. There's a Century Carbon that we have, and a Bamboo X1 there. But the reality is that, once you've made the filament very quickly, you can demonstrate something being made from it. And again, as teachers, you want to be able to teach. You want to be able to learn what you need to learn very quickly, and then move on to the classroom and repeat those results. And that's why with everything that we have, with the machines or molds, there's always pages and pages of documentation that you can go through to fill in all those gaps. And there's a little lampshade. But the next kind of more exciting segment is injection molding. And I think this is a little bit more advanced, but offers a great opportunity for teaching multiple topics. So injection molding, traditional method of manufacturing. However, often in the past, the machines would be quite large, and maybe you've heard of C.R. Clark or something like that. It could also be quite expensive. And the options often felt limited. You always need a mold to inject into, but that would mean that you would need to understand CNC, you would need aluminium milling capabilities, and we wanted to remove that. And what we realized is that you can 3D print molds. And so in front of you, there's 3 different ways of making these molds. On the right is the traditional aluminium milling method that some schools may have the capacity to do. In the middle is SLA resin. So the idea of taking a cured resin and using something like an Elegoo Mars or Saturn or something like that. And on the left is the standard FDM printing. And so, almost every school should have one of these. And this means that you actually have a huge potential to have students design a product in the class, and focus on creating something useful for recycling, and then design the mold using Onshape or Fusion 360 or something similar, and then printing the mold. And, with very limited cost, having them all print a few molds and test them out and see what the results are, and hopefully have a recycled plastic product that could be, sold later on. And so here we have 3 videos demonstrating these 3 different techniques. So the left is the 3D printed FDM, the middle was a resin one, and the right one is an aluminium mold. They all have their pros and cons, but in an educational context, they're fairly simple and fairly similar. And so on the left, we did a little benchy. They get more precise as you move up. So the resin one is more accurate. You can create nicer products. And then finally, you can do something really technical with an aluminium mold. And so those 3 options. And just, for everyone who's interested, we offer the 3D printed files for the molds, the 3D printable ones, for free to education. So you need to go to our store and use the code free, the number 4, and then edu, EDU, or free for education, as a code, and you can download all of the resin 3D print files for free. So if you have one of our machines already or thinking about getting it, then there are 3 or 4 designs there. And we actually recently did a little skateboard deck, so a little tech deck toy. It works perfectly well with resin and such. And one of the things that's been really a proud moment for us is how many places we've managed to get our equipment into. We're quite excited about, we never intended it for an educational purpose originally, but we're quite excited that over the years we've evolved for that, because the reality is that you have students in high school who are using our equipment, then going to university and seeing the equipment there as well, and then going on to a career, Jaguar Land Rover or Lush or something like that, and then again being able to continue the same tools. So they're really getting hands-on experience with equipment that they could later, hopefully, and say to their employees, no, recycling is easy. I actually know how to do this. And I just want to show you before we go, just some examples of real world usage of our machines at scale. Mull is a fantastic example that can be shown in classrooms about creating strong role models. Charlie, who works at Mull, was on Dragon's Den last year. So that's still an iPlayer now. And she pitched her homeware brand there. She collects plastic from all over her community, utilizes just injection molders and a small shredder, and produces products for major brands all over the world. She has products in Selfridges. She has products in design museums. She has produced products for Lush. So the recent How to Train a Dragon has a product made just using simple injection molding. She's done things for Amazon, etc. And she sells these products for a lot of money. So when I talked about, the idea of how much is a bottle cap worth, I mean, that ring is £18. And I can probably say there's about 2 caps in there maximum. So even as a fundraising activity, it can get quite exciting and entrepreneurial, quite easy to generate some pocket money. Yeah. And the second one, I think, is this idea of, again, using recycling to try and solve a real world problem. But again, this is very much about how much money was created. This project raised $158,000 on Kickstarter. They were selling a $75, $79 pair of sunglasses. Standard design from our website, and very easy to pick up. All the lessons are on the page, and they raised a huge amount of money. So, potentially a good way of fundraising for a project or such. But yeah, really professional. Their goal here was that they would take sunglasses and use the profits to clean up mangroves, and they would use the plastics that were washed up on mangroves. But really, they did success very well, and they went on to do more Kickstarter campaigns and raised a lot of money. And I think that highlights, teachers have a potential resource for education. They just need the tools, and whether that starts with a Bahini press and evolves, or you get grant funding and go for the idea of really teaching, sustainability, injection molding, product design, 3D printing, all in one package. It all starts with this bottle cap in reality, and it should be seen as a really valuable resource. Students have thousands of these at home, and you'd be surprised how many go to landfill every year. So a free resource, no need to buy all that extra acrylic or such, and you've got that free material around. Thanks.
Cool. Thank you, Rory. And yeah, thanks for popping the questions in the chat, guys. We'll get to those at the end. So much appreciated. Right. I think I saw Tom pop in somewhere. I'm trying to find him now. There we go. There's Tom. Right. Let me make you co-host, Tom, and then if you've got anything to share, you can share away, and hopefully it'll work. Yeah. So I'll hand over to you if that's all right.
Great, yeah, thank you very much. That was really interesting, Rory. There's so many synergies between what we both do. So yeah, it was really interesting. Thank you. Yeah, I'm Tom. I'm a co-founder at Gomi. I don't know if any of you've heard of us. We are basically a small brand in Brighton. There's 8 of us now full time. And we're trying to make the most sustainable consumer electronic accessories. So using materials like plastic waste that's deemed non-recyclable. So like LDPE, which obviously we know is recyclable. That's why I did inverted commas. And also using things like repurposed batteries from e-bikes. We're also making trophies at the moment. But the whole idea is to kind of take waste materials and turn it into products that don't have to become waste in the future. We've been going for about 8 years now. Well, I graduated 8 years ago, going officially probably like 5 years. So a bit about the material. So I guess that's why you're all here. So the plastic material that we use is LDPE. So each speaker that we make is the equivalent of 44 plastic bags that go into it. Every year, the UK throws away 300 million kilos of these flexible plastic waste. And yeah, as I mentioned, it's still deemed non-recyclable by UK councils. So you might see the little icon on the back of a lot of flexible plastic, and it is actually obviously recyclable. And I know some supermarkets are trying now to recycle it, which is great. That's a different story though. So yeah, we used that material and we basically made our own custom machine and developed it over the past 6 years using sort of compression molding technique. And we make everything in Brighton. So if anyone's near Brighton, come and visit us. We always love showing people around. We also, so it's not just about plastic for us, it's also about the batteries. So about 4 years ago, we kind of realized that, yeah, it's great using recycled plastic, but actually what are the other materials that go into electronics products? And we always had this real guilt around using like new lithium, new cobalt, and we've all seen the horror stories of that, how that gets mined with child labor, etc. So wanted to avoid that. So we only use repurposed batteries to power all of our products. Mostly come from e-bikes. We partnered with Lime, who they donated 50,000 cells to us. And yeah, you might think battery is dead, how can you use them? But often what happens is there's just a redesign of a bike, which means that the old battery pack no longer fits on the new bikes, or the circuit board could break, but the cells inside are actually fine. So all of our cells are only 95% plus capacity. I forgot to set my timer, so let me set it just so I don't go. Yeah, so a bit about our collaborations. So these are a few of the brands that we're working with at the moment. So we just made the Formula E trophies for last year. We worked with Google, Vans, Paul Smith, and I'll talk about a bit more about those projects at the end. But I thought it would be interesting just to show you kind of how it all started at university, because it didn't start with much really. It started with a baking tray, some plastic bags, and a car jack that turned into a press. And I was just basically squashing this waste material. I didn't really have much money to buy fancy materials or anything. So I was just using waste plastic bags, just trying to find things that were deemed non-recyclable and pressing it into these materials that you can see on the right. So again, it doesn't really look like much. So what I wanted to do is find a way to very quickly and cheaply turn something that doesn't look like much and kind of communicate what it could become in the future. So I guess find a method to communicate my ideas. So I used the CNC machine and just started basically milling these patterns into it, but taking photos like this. So just communicating that I have an idea to make a speaker. I don't have any money to make molds, but what I can do is mill this material into this shape and show people that in the future, this is what could exist. And that's really how it started. So for me, like communication was a huge part of the start of Gomi. This was the first speaker that I actually tried to make. So again, didn't have any money for molds. So I just CNC'd some flat sheets that I pressed and kind of IKEA style, just connected this thing together that ended up looking a bit like a speaker. Didn't sound very good, didn't really work very well. But what it did do is illustrate my idea, and also made a couple of other material ones as well. And then I showed that to new designers to say, this is what I've got at the moment. It doesn't work very well, but I've got an idea for a speaker, and kind of left it there really. But it started getting talked about. So I was really, to be fair, I was really reaching out to people and trying to share the project, and it started getting talked about in these really small kind of Instagram pages. And that was it. And then, sorry, my mouse is blowing up. Because I was at New Designers, I got seen by Somerset House, and they asked me to do some workshops. So very low tech, just using a very cheap mini oven and just some waste materials and just pressing kind of coaster shapes. I then went out to Amsterdam, did an internship for 6 months working with waste plastic, making things like plant pots, trophies for Ajax football team. That was me looking a lot younger. And still running workshops, but my speakers were still getting talked about. My idea for speakers, they weren't really speakers. And then I got a few messages. So I got one from my current co-founder now, who I had never met before, asking if he could buy them. And I was like, it's just an idea. I would love to do it in the future. And he said, well, what about if we applied for some funding, and kind of made it happen? And that was it really, kind of never looked back. And we got into the final, ended up winning, I think it was £10,000, so not much. So ended up thinking, okay, yeah, we'll start. But then went on to become Gomi. Got a full-time job, which is me on the right. But when I wasn't working full-time, I was 3D printing speaker cases and kind of developing what could be a speaker. Also thinking about how we could actually manufacture molds using compression molding for LDPE. Didn't have a clue about that. 3D printed some speaker prototypes that ended up working, and then we kind of got this space and a mold, and yeah, this was the start of Gomi basically. So pressing these speakers, testing the materials. The first speakers that came out didn't look like very much, as you can see. So just heating up the molds in the ovens, pressing them, cooling them down with a bath, really low tech, but it again, I could take some nice photos of it and communicate what it could become. So we used that to do a Kickstarter, which kind of went viral. We weren't really expecting it to. So got featured into Zine, Wired, Fast Company, all these crazy places, just from speakers that we were making literally in this room on the left. So again, I can't explain how important photos were for us. We didn't actually make the funding, which we were really gutted about. So we were like, okay, that's good. I guess that's kind of the end of Gomi. But we had a few orders that people still wanted to fulfill. So started making them. So working with this is from Infinity Foods in Brighton. So they a big food wholesaler. So they started giving us bags, and we started turning those bags into speakers, doing these kind of mini drops on our website. And then brands started reaching out to us. So Berlin Commercial, we've been working with since the start, asked if we could make trophies for them. So using the exact same process that we made the speakers, we were able to fund kind of more tech development by making trophies for brands. So this doesn't look like much as the first trophy that came out. So this is how it started. And then we managed to kind of get the flow and the melt temperature right, and ended up making this first batch of trophies for them. And we've been working with them, as I mentioned, for 5 years now, 6 years. We then got an order from Desperados for speakers for they had this idea to throw a party in Berlin and send us the plastic from the party and create all these speakers for them. So that was another one that kind of kicked us off with some funding. And then power banks. So speakers are great, but they're really expensive, really hard to make. So we wanted to make something that still added value. So started making power banks. So this is the plastic that we were getting from Infinity Foods. This was our second workshop now on the right. And we were just melting down this plastic and turning it into sheets, testing batteries, and we managed to get the finish on the power banks a lot better than what we had on the speakers. So everything we'd learned in terms of like heating and pressure, I managed to really improve the quality of the products, but still just using plastic bags. This was a launch. So we then did a launch of the power bank Kickstarter, and again, got loads of really good press from it, and actually was successful that time, which was nice. We raised £30,000, shipped them out in COVID, which wasn't really fun. And yeah, just started doing these kind of drops. So Tesco stopped taking bags in plastic bags, I think, from food orders in COVID. So we just started doing drops with Tesco bags, saying sell them to us and we'll melt them down. Probably not very COVID safe at the time, but we made some cool products out of it. Skip through this. So yeah, so the speaker that we did do originally was a plastic back and a plastic front, but it wasn't very durable. It was kind of really early sketch for a speaker, really. So we wanted to improve it. So we threw another Kickstarter for the speaker, and this time using the kind of batteries, the repurposed batteries. I reached out to Lime, as I mentioned before. So this on the left is all the batteries at Lime that we got donated. So 50,000 cells, and yeah, I just reached out to Lime and asked if I could have the batteries, basically, and they said yeah. And part of that was because we recycled it for them. They let us use their marketing team to help us launch it. So they did a really big push and got it into the Telegraph, Mashable, Verge, and it was really cool. Like we got a lot of exposure for again a product that was just made by hand from waste in Brighton. It's a fun little gift that we made. I launched it and it was a successful Kickstarter and actually won an award at Milan. So that was me. Again, in COVID, I couldn't travel from the UK, but yeah, won an award, which is quite cool. So taking all those learnings again, we wanted to do something that we could actually sell quite well on Instagram ads to fund the company, to fund that growth. And everything up until then had just been Kickstarters. So in 2023, we decided we were going to do a launch of a product that could sell on ads. We could sell in stores, still made in Brighton by us. So this was the next design that we did. So hundreds of 3D prints, getting feedback, running open days, inviting people in, doing renders, and ended up with this speaker design, which was easy repairable. So no glues at all, just screwed together. Customizable metal, so we could engrave it with branding, if you want to talk about brands or custom, whatever. And also engraving an edition number into each one, just to kind of add that art touch that would add some value to it. These things still take a lot of time to make. So one of the big things we've had to learn is how do we add value through like design features or the packaging or whatever it is, the storytelling. We need to add value to it because otherwise it's just perceived as a waste material. So we launched the speakers and sold them to stores. So we launched it at Paris Fashion Week, and yeah, we got into Design Museum, Selfridges, MoMA in New York, Museum of the Future in Dubai, like all these crazy places, which was really cool. But it was then really hard to sell on ads. So, which was great. We got into these stores, really good branding, but an expensive product was kind of hard to sell on ads. So we started testing new product ideas, smaller speakers, power banks, but we found the power bank actually performed the best on ads and meant that we could grow to profitability and invest all that money into new material testing, new product testing. So we launched these ads for power banks in 2024 and quadrupled our revenue with this launch. So it was a really big thing for us. And making all these really fun, nice patterns as well. A lot of them are made using our offcuts. So yeah, these are the power banks on our website. How am I doing for time? I think I've got a few minutes. Sorry, I'm racing through this. Yeah, so that was the power banks in 2024. And then this year, we really wanted to launch some new products that, again, added value, replaced products that are just glued together and single use. So the 3 products that we did that we've launched after our tests were wireless charger, phone cases, and tags, so tracker tags. To do this, we had to raise some money. So we did a Crowdcube campaign over summer. So we raised £250,000 over summer from angel investors and Crowdcube, telling the story, what we wanted to achieve, how we were going to do it. And these are the 3 products that we launched. So we launched them literally a couple of weeks ago now. So yeah, it's been a lot of work to get them out. But the wireless chargers are just screwed together, no glues, tags the same. And phone cases that are literally just plastic pressed in Brighton. There's nothing else to them. So replacing hopefully single-use phone cases with one that when you get a new phone, you can send your phone case back to us and we'll repress it into the new model. Or if it gets old, it gets scratched up, send it back to us and we'll repress it again. The tags were actually really interesting. So the first product that we've really tried to work on a texture in the mold. So it's something that we hadn't done before. But as I mentioned, these design features that add value to products and make something feel worth more. Texture has been a huge thing for us. So something that we're going to be really working on next year is getting texture onto all of our products to make them more scratch resistant, so they last longer, and they also just feel better as well. So the phone case, we just had some features today, which is really cool, in wallpaper. And then just to end on a couple of fun collaborations. So a lot of what we do is collaborative brands. So this is one with Paul Smith. We've been working with them now for 2 years, making speakers, wireless chargers, cables. So Paul basically designed this stripe. Everyone's different, but still has a kind of similarity in the stripe. And yeah, that was a really fun one, super colorful. Launched it in all their stores. This is the video that we did. You can see. I don't know if this is playing for you. Maybe it's not. Yeah, you get the idea. So just as you saw there in the video, it's just pressed in a compression mold. So exactly like I was doing at university with a car jack, but just been developed and developed and developed so that we can produce really good finishes every time. In the early days, we were only pressing 3 speakers a day on like 12-hour days. Now we can make around 100 speakers a day on like an 8-hour day. So yeah, it's been a massive improvement. Especially mainly from our engineer Kyle, who came on board as a co-founder. He's amazing. So he's just been developing our molds and all of our presses. We also work with Vans, but they launched a new store in the West End. So we looked at their pattern, made them a kind of checkerboard pattern, and used it to help them promote their opening in their store. Vans need the product of the store. Yeah, so we basically made this checkerboard pattern in a heat press and then put it into a compression mold and kind of sealed it in, cooled it down, and it was left looking like a Vans checkerboard, which is pretty cool. So made stuff for Antler. These are the Formula E trophies that we've done. So we worked with Central St Martin's last year, where 3 students pitched the design for a trophy, and we kind of helped them get to the finals for this brief, and then the client then ended up choosing this design, which is quite cool. And we've been manufacturing them ever since. And finally, I'll show you a fun one to end because I think I'm nearly up. But when the Barbie movie came out, we had an idea to reach out to our community and our newsletter community and ask them to send us their old dolls, like broken dolls. So they sent us literally boxes and boxes of these dolls arrived at Gomi. So we crushed them up and turned them all into speakers and sent them back to the people who had sold us the speakers. So the idea was that you could have something sentimental that you would never want to throw away, because it was your own toys, your childhood memories, we called it, that was kept on your shelf, which is quite cool. So yeah, it's recycling. Some people might view it as less valuable, but I think this project really showed that actually you can really tell a clear story and something that you can make a product that someone's never going to throw away if it was made from their own memories. Here's a little video about it, which is quite funny. 27th of July, Barbie drop, coming soon. Don't miss it. We made speakers for this limited drop out of old Barbies that we found, waste Barbies, broken Barbies. We've melted them down in our studio, we've crushed them, we've taken them apart. We've had a lot of laughs. We've had a lot of laughs because it is quite brutal. They were going to go to landfill, they were going to be incinerated. So we decided to save them and give them another life in our speakers. Yeah, you can watch the video on our Instagram if you like, but you can tell that we don't really take ourselves too seriously with sustainability. I know it's a really important subject, but I think it's important to have a laugh as well in what you're doing, as well as have an impact. So we try to do that. But yeah, thank you very much. I think I'm over by a minute, so sorry.
Awesome, but brutal in equal measures. I love it. I love it, Tom. Thank you very much. Cool. Right. Let's see if we can tackle some of the questions in the chat. If there is anything else that you want to add in, please add them in. So the first one from Paula, are you prepared to share temperatures and templates with the wallets? I think that was probably yours, Pat, was it?
Yeah, I've made some notes on that. Yes, I will share them. What I do is I put them into the Facebook group that I've got there. There's a file section in there. I'll probably drop them into there. Some things in there. That's probably the easiest way to share it. So I know some people joined that Facebook group, which is great. And someone asked about how we make the wallets. We use a t-shirt press, but I put all that information into that. I collate something over that because I've got it on a slide, so I should put the slide in there from it, sort of thing like that. What I show to students how we run through it. But you resonate a few things there, like what Rory said and what Tom said as well. I've done all this plastic recycling to bring it to life, rather than watching a YouTube video or just talking about looking at textbooks somewhere to actually actively do it. We made the machines because someone said, how do you make them safe? That's all. Like, I'm from trade and engineer, so we looked at things like that. But that was the problem solving with students as well. How do we make it safe? That was iterations of doing things, and that was a real big thing of doing that. The iteration of how do you make it safe? How can you create things that on there are safe? But it's a possible thing to do depending on the skill set you have in your department. I'm lucky to have a technician who's a fabricator, and that really helped us having that, the fabricator, because he was able then to, come in and say, oh, let's do it this way, let's do it that way. Students, because we prototyped everything as well first, before we made the things. So I hope that's answered some of the questions there.
Cool, thanks, Pat. And Rory, I don't know if you want to add anything in terms of safety of your machines and things might be useful.
Yeah, exactly. So I think all our machines, are certified. So that's also the kind of process that if you're making it yourself, fine, you embark on the journey yourself. When it comes to fully assembled pieces of equipment, our injection mini was designed with safety in mind. So it's a fully enclosed design. So you cannot, trap any fingers or such. And the same with the shredder, so the shredder is designed with safety in mind. They're all regulated. It's when you start building things yourself and start looking at, parts and pulling together online, then you take on the responsibility. And as soon as it's not delivered to your door as one thing, then you're taking on responsibility. So yeah, the safety perspective, go for something built, or embark on the journey, but understand that you'll need to seek probably Pat's guidance in a lot of ways because he's done it.
Oh, thank you.
Come back in there again on that one, because we had the council came and checked everything as well. Because we're a state school, and you get the health and safety audits and everything like that. And he came in, actually looked at the machines. He said they were really safe. How we thought about it, because I can tell you one thing. I had one year, the year 13s, they were literally climbing all over the machine, thinking, "What would a year 7 do? Try and get his hand in here. Let's put a guard on this one." Well, thinking that mindset, and that really worked for problem solving really well for a lesson, sort of thing like that.
And also just to add as well with Cleeps. I don't know if you guys will know of them, but they have our equipment developing standardized resources for them on that health and safety front.
Cool, brilliant. Probably another one for you, Rory. When printing the mold, what will you use to print, and what do you injection molds?
Sure. So all of that information is on the resources section. So on our website, resources, and then you scroll down to 3D printing. In a nutshell, when we're printing a mold, we're either using polycarbonate blend. So this is either from Bamboo Labs or Prusa. This is one of the durable ones. It's relatively affordable. I think right now polycarbonate's going for maybe £29 on Bamboo on website, so it's not too expensive. We put it in an aluminium hold or housing. That's on our website as well. And then when it comes to resins, we use a brand called Frozen. That's PH Frozen. And it's TR300. This has a temperature resistance up to 280 degrees. And in most cases, you're just injecting polypropylene at 200 degrees. There's a lot of, if any of you are on Instagram, such, or YouTube, there's a lot of videos showing this process over and over again. And there's even a full video which I did on YouTube last year, where I walk through every single stage and the pros and cons of each. I can jump that link into the chat.
Cool, that'd be brilliant. One for you, Tom. I think apart from people wanting to crush Barbies, how do you get the clean pinks and the specific colours like the Paul Smith collab that you did?
Yeah, good question. So we used to just use the plastic that we had from like shops or restaurants or Infinity Foods or whatever. But when we scaled up, we couldn't replicate that color over and over again. So we worked with a recycling company who basically everything kind of arrives to us like gray, kind of a gray color, and we can add a master batch to it. So we can dye it basically any color that we want. So you had, I think it's like less than 0.5% of master batch, which means that we can match any Pantone color. So when working with brands, that's really useful because they'll have a very specific Pantone that they want to hit. So that can either be mixed in by hand on like a really DIY scale, or if you want to, if you want a more effective color, you can mix it with I guess kind of an injection mold, but it's not really injection mold, an extruder. So you can mix it at really high temperatures and high pressure with an extruder. So yeah, master batch basically we use.
Brill. Can we bring a small group of students? You opened your mouth and said, "Come and see us." So you've opened the floodgates. Is that okay?
At some point, yeah. We'll just need to arrange a date and the right time, etc. We're really, really busy at the moment, but it obviously isn't always this busy. But yeah, I love having students in. We have quite often have the university students in from Brighton. So yeah, just drop me an email. I put my email in the channel.
Brilliant. Yeah, I saw that. Thank you very much. What else have we got? Don't think my school can afford much equipment. Are there any ideas for doing plastic recycling that could be affordable? I don't know if anyone wants to answer that, Pat.
Yeah. So what you can do is if you approach your councils, the council where your school's in, or even the waste management there, because I managed to get all this, our filament maker, the 3D printer, the whole setup. I got that as a grant off, them. I just put together what it was, pitched the idea to them, and they came back and they gave me £600 as grant money, sort of thing like that for it. So it's only small things, but small things start things off that way, you know what I mean?
I think Tom showed that brilliantly, from university, sort of starting small and building it up. And I know you've done exactly the same, Pat. Real. One from Phil, question for Rory. What level of outlay would we need to set up the filament making activity?
What do you mean with outlay?
Presume what do they need to get to start making filament out of bottles?
So the filament maker on its own is a complete little kit. You'll need like little basic tools that you have around. So a pair of digital calipers, and some kind of ventilation of some kind. You just want there to be, you can use a soldering extraction or something like that. Then you just need a 3D printer. And you can basically go from there. It's pretty minimal. The only thing I was thinking of is you need to inflate the bottles and heat them up. So, a small bicycle pump might be something that you would have as a little extra. But they're realistically, as a bolt-on, you're talking 20, 30 pounds extra, maybe, if you haven't got them.
Well, thanks. John's given a little tip there for people that don't have access to a shredder. Thank you, John. Rory's popped in a video as well. And Trudy's also given a bit of help to Liz about some funding. What temperature would you melt bottle tops from Sophie? Pat, I don't know if that's one for you. What temperature do you do bottle tops at?
Well, depends if we injection mold them or if we put them into the oven. But HDP has a melting temperature. So, we do it around 150 to 180. That's the melting temperature for it. But if you put in a panini press, it will do it after, silicone sheets obviously with it. You can't just put it directly into it. Takes a couple of minutes and they start forming. You can see it when it pulls apart, and stuff like that. And again, it depends if you leave the bottle top as it is or if you shred it down, that makes difference with timings as well. And probably an advice is to do up so the openings towards the top when you're doing it, otherwise you get air pockets.
Yeah, and on that temperature front, if you are injection molding or doing anything like that, we have a page on our website which is about material. It's a material database. So the idea is that on there we will have tested different materials, whether it's DVD cases or bottle caps or whatever, and melted it, and then we publish our results. And so it shows you what you can expect to achieve at what temperature. It is using the injection mini as a baseline, but it is a good gauge of kind of guessing or seeing what we've done in our tests. And if you have material that you want tested very specifically, let's say 2 kilos of Coca-Cola bottle caps, and we don't have it on our database, you can send it to us and we'll test it for you and publish it for everyone to see. And then it's added to that database.
Cool. Sounds really useful. And one final one for you, Pat, about do you need to put together any sort of business plan, proposition for approaching the council?
Well, there's 2 ways of doing it. One, I invited the council in just to show them what we were doing. That really worked very well because we're a big school. And the other one was, it was just, I searched around, approached the councils and asked if there was funding available, you know, and once they said yes, then I put together a letter to them, you know, and explain what we're doing. So it didn't have like a business plan as such. It was more like a letter saying, this is what we're doing, you know, laying it out. One year, actually, the students done a video that they'd done, you know. So I had students talking about what we wanted to do. It's quite an old one that we have there. They talked about how we recycled and how we wanted to do more. We've done a fundraiser for it, but no particular format or something like that, you know. You probably find around, if you ask around your school, there'll probably be a parent that works there somewhere or something like that. And that's always a good way in, because otherwise the email just ends up somewhere sitting in the council.
Not what you know, it's who you know. Yeah, and you use the kids to play on the heartstrings. Definitely good advice. Well, thank you very much. We're bang on time. That never happens, so that's awesome. I just want to say a massive thank you to Pat, to Rory, and Tom for giving their time. And we knew you were always going to make it, Tom. We weren't worried in the slightest, so all good. But thank you to everybody else as well for turning up today. You're nearly on the home straight. Have a fantastic Christmas when it comes. And hopefully we'll see you all in 2026. But thanks again, and we'll speak to you soon. Take care. Have a good evening.
Thanks, everyone.
Thank you.
Cheers, guys. Thank you.